the James Webb Space Telescope revealed the startling discovery that, 7 trillion kilometers from Earth, there seemed to be metropolitan light in space. This important finding has sparked interest in the possibility of alien life. Proxima Centauri b, the nearest exoplanet to Earth, was the focus of the telescope, which revealed strangely intense lights coming from it. Could the existence of life beyond our planet be indicated by the origin of these city-like lights on Proxima Centauri b? Come learn how the James Webb Cosmic Telescope discovered these extraordinary cosmic phenomena. The idea of extrasolar life has been conjectured and studied for years by scientists and the general public. Any proof that this cosmic fantasy is real has been enthusiastically embraced. When the James Webb Space Telescope recently revealed convincing evidence of living things existing in space, established scientists were shocked. Strange city-like lights shimmering from the exoplanet Proxima Centauri b were picked up by the James Webb Space Telescope when it was scanning space and sending data back to Earth. As their name implies, these lights seem to light up a faraway city. Researchers are in awe at the possibility that this star may support an alien metropolis. They are perplexed because this may be the arrival they have all been waiting for. If this turns out to be as likely as many think, it means that sentient species are building civilizations in space that humans are not yet aware of, and we are just now starting to discover them. NASA experts are wondering how long the city lights that were discovered 7 trillion miles from Earth had been blazing in space, waiting for humans to create the technology required to identify them. Columbia University space scientist David Kipping says the city lights on the Proxima b exoplanet were fascinating. He said that this is the case because the heat patterns of the star system nearest to us fluctuate and are different from those of other worlds. Proxima b is not known to absorb sunlight or emit infrared radiation as most rocky planets do. Its infrared properties vary significantly from those of Proxima Centauri, its host star. This implies that a key observation of Proxima b by the James Webb Space Telescope, JWST, which can detect infrared frequencies, has identified a distinctive heat signature of Proxima b that will be essential in solving the atmospheric riddles of the planet. Researchers anticipate using the JWST to evaluate the likelihood of life on this exoplanet and to unveil the mysteries of its environment thanks to advancements in infrared imaging technology. Because of its infrared sensitivity, the James Webb Space Telescope can see what occurs on Proxima Centauri b at night and pick up even the smallest light beams in the midst of complete darkness. For space telescopes, this is usually a problem, but not for the JWST, which is able to detect even the tiniest light emissions from space. It is the ideal instrument to confirm whether the reports of city lights on Proxima's night side are accurate. The telescope can detect any artificial lighting in the universe as long as it occurs in a frequency band 1,000 times smaller than starlight. Proxima b has a fascinating relationship between its surface features and celestial elements. In addition to reflecting incoming light beams, the exoplanet's spectral edge has a large array of solar panels on its daylight side that capture the star's radiant energy. Proxima b has day and night cycles like to those on Earth as it completes its circle around its host star, Proxima Centauri. During the day, it is exposed to intense solar heat, and at night, it cools down. It is well known that the planet's composition causes its temperatures to fluctuate. For instance, the change between Proxima b's day and nighttime periods would be very sharp and quick if there is no atmosphere. The temperature will be very hot during the day and chilly and gloomy at night if atmospheric gases don't have a moderating impact. One important topic for astronomers to study is the degree of temperature change, which will help them better understand the makeup of Proxima's atmosphere. The JWST's unmatched infrared imaging capabilities will make it possible to analyze the planet's thermal emissions effectively and give important insights into its atmospheric characteristics. Strangely, Proxima b's orbital period coincides with the James Webb Space Telescope's orbit around the Earth, enabling in-depth investigations of its day and night phases in only 11.2 Earth days. The next stage will be to evaluate Proxima b's atmospheric chemistry to see whether it can sustain life, since it does have an atmosphere. Important indicators of life include the existence of chemicals like oxygen, water vapor, and methane. The presence of these components on the planet would indicate livable circumstances. Researchers must exercise caution when capturing and analyzing light beams passing through the planet's atmosphere in order to effectively determine this. This is a difficult task for future telescopes to complete. Despite the JWST's remarkable capacity to describe planetary atmospheres, the powerful instrument is limited in its ability to peer at a small number of the closest exoplanets to Earth in order to perform intensive atmospheric examinations. These days, astronomers are focusing on ground-based observatories such as the Extremely Large Telescope, ELT, which is scheduled to start operations in 2028. The ELT will investigate distant exoplanets' atmosphere structures and provide detailed information on their habitability. Future space telescopes like this are widely anticipated by NASA researchers and the general public. The James Webb Space Telescope will continue to be a vital instrument in our investigation of far-off exoplanets. Until then, the JWST has the capacity to provide significant findings that might fundamentally alter our comprehension of exoplanetary exploration, notwithstanding its present constraints. In order for astronomers to better view the reflected light from a planet, researchers have set a target for future space telescopes to decrease the brightness emanating from the planet's parent star. They intend to accomplish this by using internal masks or massive external spacecraft shaped like parasols, which are similar to shielding your eyes with your hand to better see an object under sunlight. By reducing the intense brightness from a host star, future telescopes will be able to focus on faint reflections from far-off exoplanets, enabling a more thorough analysis of their atmospheres and the possibility that they could support life. Nevertheless, this task comes with its own set of difficulties. Gases produced by biological activities and those resulting from geological events like volcanic activity must be distinguished by scientists. In order to identify true signals of life and distinguish them from false ones, astronomers are still committed to learning more about the characteristics of exoplanets. A preview of scientific advances in the study of exoplanets, the James Webb Space Telescope provides an insight into the incredible discoveries that lie ahead. As we deepen our understanding of the universe, the mission continues. Our understanding of the complex workings of the cosmos and our special position within it grows as our investigation of the cosmos progresses. Researchers have searched in space for many planets, but they have not yet found one that is habitable. The search for evidence of life things in the cosmos has continued for decades. Since ancient times, people have wondered whether we are the only beings in the cosmos. Therefore, this timeless interest is still relevant today. Researchers continue to use the James Webb Space Telescope in orbit to look for signs of life on many planetary bodies and try to find extraterrestrial cultures hidden amid the stars. Simultaneously, a generally accepted hypothesis has surfaced lately suggesting that there may be extraterrestrials in the cosmos waiting for mankind to find them. Two American astronomers, Jill Tariter and Thomas Pearson, started the Search for Extraterrestrial Intelligence project in 1984 in an effort to answer this persistent question. SETI, currently known as the SETI Institute, this non-profit group seeks to detect radio signals from space by analyzing astronomical emissions. The reason for the emphasis on radio waves is their ability to travel great distances without being absorbed or dispersed. Because of this feature, radio signals have a higher chance of being picked up by the 42 radio dishes that comprise the Allen Telescope Array, which is situated in the Cascade Mountains of California, than many other types of radiation. Despite the SETI Institute's painstaking search for radio signals that could be coming from extraterrestrial civilizations, no verified transmissions have been detected in well over 30 years. Jill Tarter, however, is upbeat and says she wants to enable people on Earth to participate in the last hunt for sentient life beyond our planet. This effort went on until recent NASA studies suggested that metropolitan illumination may have been detected on a planet close to Earth by the James Webb Space Telescope. Humanity's most potent instrument for solving the universe's secrets is the JWST. It was launched in December 2020 and is now the most sophisticated infrared observatory ever built. The James Webb Space Telescope is equipped with cutting-edge optical equipment that led it to see through cosmic dust and uncover hidden facets of the cosmos. Its main goal is to probe deep space for the first stars and galaxies that originated billions of years ago. Named in honor of James Webb, a trailblazing NASA executive who was instrumental in the Apollo lunar landings and space exploration. The telescope has a unique set of equipment that cooperate to provide unparalleled cosmic insights. One of them is a near-infrared camera, NRCAM, a fine guidance sensor, FGS, a mid-infrared instrument, MIR, and a near-infrared spectrograph, NIRSpec, that guarantee the telescope maintains its precise location while viewing far-off objects. The James Webb Space Telescope's massive mirror, which is composed of 18 hexagonal pieces, was painstakingly designed to catch the faintest light from the earliest galaxies. The telescope can detect even the faintest thermal signals from distant celestial bodies since it is designed to operate at very low temperatures. Since it was deployed, numerous discoveries about galaxies, exoplanets, and stellar phenomena have been made possible by the JWST's amazing photo captures and groundbreaking data transmission. Although these topics have been its primary emphasis, the unexpected discovery of city-like lights has led academics to reconsider the possibility of alien civilizations. Scientists are currently investigating the startling discovery of apparent city lights on Proxima Centauri b. Because of the telescope's capacity to explore the furthest reaches of space, mankind is getting closer to finding the answer to one of the most important questions of all. As scientists continue to examine these peculiar and unusual lights on Proxima Centauri b, many concerns about the next stages in unraveling the mystery of extraterrestrial life emerge. Are we alone in the universe? One of the main mysteries is whether these lights are man-made. Some theories claim that these lights might be proof of intelligent life forms with technical skills or even naturally existing luminous species creating light in unexpected ways, given the regularity and intensity of the emissions, which imply they may not be the result of natural sources. Many preconceived notions about the limits of life in space are challenged by the notion that such structured lighting could originate from a planet so far away. However, it is still possible that what seems to be artificial lighting is actually the result of peculiar natural activity that is still poorly understood. According to some scientists, these apparent patterns might be the consequence of infrequent atmospheric interactions connected to the planet's tumultuous environment or to energy from its stellar magnetic interactions. The atmosphere of Proxima Centauri b may include radiation belts and intricate chemical reactions that might provide impacts on the telescope sensors that mimic artificial lights. But this notion is still up for discussion and needs further research. Future research will concentrate on observing how the light emissions change over time and determining if they exhibit organized or recurring behaviors in order to address this. Because of its ability to observe continuously, the James Webb Space Telescope is well suited to gathering information on whether these emissions are constant or vary in a manner consistent with technology-based activities such as manufacturing facilities or electrical grids. Sustained observation is necessary and might ultimately provide important information to solve this puzzle. Simultaneously, as scientific methods and equipment advance, scientists expect to use progressively more sophisticated technologies to examine exoplanets. Next-generation observatories like the Extremely Large Telescope, ELT, and future space missions will provide additional capabilities to detect planetary signals and recover data that enhances the findings of the JWST. These platforms working together will establish a cooperative system of cosmic investigation that may verify extraterrestrial existence or at the very least improve our understanding of other planets and their capacity to host life. The concept of identifying sentient entities by analyzing far-off planetary illumination ushers in a new era of scientific investigation as the hunt for extraterrestrial life continues. Even while mankind has not yet confirmed the presence of aliens, every odd finding, whether it be an odd signal, an inexplicable light source, or a perplexing anomaly, brings us one step closer to the solution. Finding extraterrestrial life would have enormous ramifications for science, philosophy, and society. Understanding that we are not alone has the potential to drastically alter how we see our position in the universe. Furthermore, the possibility of exchanging knowledge, culture, and maybe even interplanetary technology might mark the beginning of a new era in human history if the existence of sophisticated civilizations is confirmed.